There's a moment in Cold War history that often gets overlooked, buried beneath headlines about nuclear standoffs, proxy conflicts, and political brinksmanship. It's the quiet reality that entire regions were so cold, so hostile, and so remote that any strategic outpost needed more than walls and heat. It needed a shelter capable of resisting blizzards that could bury vehicles, freeze machinery, and turn a lightly built structure into splinters in a night. For the first minute of this exploration, it's worth staying with that truth. During the Cold War, survival wasn't just about radiation or blast waves. It was about enduring some of the harshest winter conditions on Earth. Arctic wind speeds reached hurricane force. Temperatures sank to levels that could shatter metal. Snowfall buried antennas, supply caches, and sometimes entire buildings. And yet one shelter design not only survived those extremes, but thrived in them, proving so effective that modern polar research stations still borrow its core principles. Now let's move directly into the shelter's construction, why it worked, and how the lessons from that era can be used today by survivalists and cold region homesteaders. Cold War strategists learned that a shelter had to work with winter, not against it. The most successful Cold War blizzard-resistant shelter was the earth-bermed, low-profile reinforced structure that used the landscape as armour. Engineers and military planners discovered early on that traditional above-ground buildings simply could not handle Arctic storms. Walls collapsed under snow load, roofs iced over, heating systems failed. The answer wasn't to build taller or stronger. It was to build differently. By burying the shelter partially into the ground and covering the structure with packed snow or soil, designers created a natural insulation layer that modern survivalists still rely on today. Any survival-minded person can apply this principle in a practical way. If you're constructing an off-grid winter shelter, pushing earth up against the sides of the walls, even 2 to 3 feet, will dramatically increase interior warmth and shield the structure from wind. A simple step like this lowers heating requirements and reduces the strain on fuel. During the Cold War, this was critical. Supply convoys couldn't always reach remote stations during winter, so conserving heat meant conserving life. One of the defining features of Cold War blizzard shelters was their cylindrical or arched design. Engineers used hardened steel Quonset-style frames or reinforced concrete vaults because curved structures distribute weight evenly across the arch. Instead of allowing snow to accumulate dangerously in one spot, the shape transferred the load into the ground on both sides. Blizzards that would collapse flat-roof buildings had little effect on these structures. To apply this principle today, anyone building a winter-ready shelter should avoid flat roofs entirely. A simple arched cattle panel greenhouse frame, reinforced and covered with plywood or steel sheeting, mimics the structural strength Cold War engineers relied on. Even for temporary shelters, shaping the roof into a steep pitch or curve reduces collapse risk and, minimizes the labor of constant snow removal. The Cold War blizzard shelter didn't depend purely on heaters. It relied on thermal mass. By burying the shelter and using thick walls of concrete or steel insulated by earth, it trapped warmth and slowed temperature swings. Even if heaters failed, the interior often stayed above freezing, which was a life-saving feature in environments where, honestly, stepping outside to repair a generator could be fatal. This lesson is one of the most practical takeaways for modern survivalists. A shelter with thermal mass, stone, earth, concrete, packed snow, or even water barrels retains heat far longer than a lightweight structure. So, if you were building a winter cabin, adding, say, a concrete bench, an earthen berm, or even a wall of filled barrels near the heat source actually creates a kind of heat battery that continues radiating warmth through the night. Cold War engineers weren't just guessing at this. They were applying, really, centuries of Arctic building knowledge to modern materials. A common danger in blizzard regions is, well, blocked vents. Without fresh air, carbon dioxide builds up quickly, especially when heaters are running. The Cold War shelter solved this by using angled ventilation pipes with protective hoods and manual pumps that could draw fresh air even when intake points were buried under several feet of snow. For a modern application, anyone constructing a winter shelter should include at least 2 independent ventilation channels at different heights. One low intake and one higher exhaust will naturally circulate air. Angling the external vents downward, prevents snow from falling directly in. Adding a simple crank fan or manual airflow device ensures that, even during power loss, breathable air continues moving through the space. This was standard practice in Cold War Arctic stations, and, it actually remains standard today in research bases across Greenland and Antarctica. Cold War designers recognized that blizzard resistance meant psychological endurance as much as structural strength. A shelter that could resist a blizzard was only useful if people could live inside it for days or even weeks without resupply. That meant efficient layout, low-waste heating, secure storage, and interior organization that kept sleeping, eating, and equipment areas functional, even during prolonged confinement. Cold War shelters were compact, but never cramped. They were organized so that daily tasks continued smoothly, despite storms outside reducing visibility to 0. A practical version of this for survivalists is, straightforward. When building or retrofitting a shelter, it's important to dedicate clearly defined sections for warmth, food, tools, and rest. Keep the coldest area near the entrance as a buffer section, and the warmest deeper inside. Cold War shelters taught us that order was a survival tool, not a luxury. The Cold War blizzard shelter remains relevant because it was built on necessity, not theory. Modern prefab shelters, often prioritize appearance, portability, or short-term convenience. Cold War shelters didn't. They were built with a singular purpose: to endure the worst winter, can deliver while protecting the people inside with no external support. That focus on raw functionality is why the design still outperforms many modern structures. The lessons remain clear. Build low, build strong, use earth as armor, rely on curves, add thermal mass, and design airflow that works without power. These principles kept Cold War personnel alive in places where blizzards could last an entire week. They will serve anyone today seeking resilience against extreme winter environments. If this deep dive into Cold War engineering brought value to your understanding of survival history, make sure to subscribe to In the Beginning. Share this guide with fellow history and preparedness enthusiasts so we can continue exploring the designs and lessons that shaped real-world resilience.